Hey guys, this is Encrypit. It's a hidden calculator encryption vault. The calculator operates as a normal calculator would until you enter a specific expression and hit the equals sign, at which time a second activity is launched. This second activity displays a text field that the user can encrypt and decrypt the contents of. The calculator is XML text views in a column of rows for buttons and two display fields for the expression and the result. If the numbers in the expression field don't match the numbers the passcode requires, it operates as a normal calculator would and displays the result. Once the user is through the calculator and in the encryption application, they can edit the text in the text view field and either encrypt or decrypt the contents of it. My application uses Android cipher class to generate a cipher object that performs encryption methods on the plain text given to it. When instantiating the cipher object, you have to pass in the transformation function, the padding mode, and the block cipher mode, as well as your secret key. This cipher uses AES encryption and the GCM block cipher mode with no padding. The cipher's initialization vector is needed to generate the decryption cipher, so we set a reference to it after the cipher is initialized. Before the user can either decrypt or encrypt the contents of the text field, they need to specify a key alias. To do that, the user clicks on the key alias button and inserts a unique key ID. The same key is needed to decrypt. If the incorrect key is given, a toast dialog displays that the encryption is a failure, and if the correct key is given, a toast dialog displays that the encryption is a success. I use the Android key store system for storing the keys. This is a cryptographic key container that makes it difficult to extract the keys from the device, so that they can be used for cryptographic operations from within the container while remaining non-exportable. The decryption method of the cipher requires a secret key and a GCM parameter spec object to be instantiated. This GCM parameter spec object is instantiated using the same IV that we passed out on cipher generation during decryption, as well as the total bit length of the GCM. This is done so that the block mode cipher operates under the same IV and bit length as the encryption cipher did. In order to obtain the secret key required by the cipher initialization, a key store instance is created so that we can retrieve the same key used during encryption. This key is generated using a getEntry method and then initialized to a secret key object. Once the GCM spec and key objects are instantiated, the cipher is initialized with these two objects, and the doFinal method is called on the cipher object with the test file's bytes as input. The resultant bytes are cast to a string and written out to the same file. Both encryption and decryption read and write from the same file. So this is a quick demo of the Encrypit app. It operates as a normal calculator would, doing with your normal expressions, until you enter the passcode. 42, for obvious reasons, is the passcode I've set for this one. And there's some sample secret text. It can't be encrypted until there's a key alias given. So it doesn't quite matter what you put in, it's just for reference. And it's encrypted, written out. Now, if we were to overwrite the old password, you couldn't decrypt because there's no reference to that key. It's the incorrect reference. So we have to reference the correct key for it to be used in the cipher, and it's decrypted properly. This calculator password was supposed to be that so you could edit the password to get into the encryption app. I got that like 80% working with shareable preferences, with Android's shareable preferences. Didn't get it quite close enough, but the dream was there. And that's my app. Thank you for watching.